And in comparing two proportions, we can do a confidence interval like we did earlier in Chapter 9, or we can do a test of significance about the difference, either one about the difference of the two proportions. And our four-step process is the same. There are some slight differences. Let's start with the confidence intervals. First of all, we state the parameters we want to estimate and what's the confidence level. We're going to define both of the different proportions because we have two of them, and then state our interval. So it's the same kind of thing as before. We want to find a blank % confidence interval for the true population. You say your parameter of the whatever the context of the problem is. When you're planning with the two proportions, you're going to talk about the inference method. So here we're going to do a two-sample Z confidence interval for, and then you're going to say P1 minus P2. So when you're talking about the very first line in each of these processes, that's why in the past we've been writing them down. At that time it was the only thing that we were doing, but now there are many more tests, so we have to make sure that the reader knows what we're talking about. As usual, you have four parts. Besides saying the test that you're going to do, you're going to talk about the random sample. When you're talking about sampling distributions being normal, now since you have two different proportions, you have to show that both of those proportions are normal. And then for independence, you're going to show that the population is 10 times your sample as usual. We have a new formula. You don't have to memorize any of these formulas. They're all on your sheet. And so here, when you're doing an interval, instead of having just the proportion plus or minus something, you have the difference between the proportions plus or minus your Z for whatever confidence interval you're doing. And you'll notice that we have that square root thing again, but since there are two proportions, it's the same thing as before, but you put both of them in there with a plus sign. No big deal. And then last, our conclusion, we interpret in the context of the problem with our same kind of statement as before. We're blank % confident that the interval from blank to blank captures the two parameter, put it in the context. Let's try one. So many news organizations conduct polls asking adults in the United States if they approve of the job the president's doing. How about President Obama from August of 2009 to September of 2010? According to CNN, 1,024 randomly selected U.S. adults on September 1 and 2 in 2010, 50% approved, and in 2009, 53% approved. So it kind of looks like, when you look at the numbers, that his approval rate dropped from 2009 to 2010, right, by 3%. So we're going to use the results and construct and interpret a 90% confidence interval for the change in Obama's approval rating among all U.S. adults. So step number one, I'm going to start writing at the top because I'll probably run out of room if I don't. We will find a 90% confidence interval for the true proportion change in President Obama's rating from adults from 2009 to 2010. Whoops. And then we should also, of course, define what our different proportions are, our P's. So we're going to say that, I'm going to call it P10 for the proportion in 2010. And that's going to be equal to the true proportion of U.S. adults in 2010 who approved of Obama. And then I'll call P9, that's not an A, it's a 9, the true proportion of U.S. adults in 2009 who approved of Obama. And since you might have more room on your AP test, maybe you should write out the whole sentence. Maybe you'd say something like, in August of 2009, in United States adults, blah, blah, blah. So maybe be a little more detailed when you write it out, I guess. In our next step, in our planning step, we're going to talk about all the different pieces. So we will do a 2-sample Z confidence interval for the true proportion change in Obama's rating from 2009 to 2010. We have 2 random samples of 1024 and 1010, was it? U.S. adults. Both samples are independent since the population of U.S. adults is at least 10 times our samples. And then we are going to check for normality. So to see if it's normal, remember, since we have 2 proportions now, we have to check both of them. So we've got to check the number in our sample for our first proportion, the P10, which is our sample, and see if that's greater than or equal to 10. And when we do that, we find out when we multiply those 2 numbers, the 1,000, was it 1,024? Times our proportion, we find out that the number is going to be 512. And that's greater than or equal to 10. I'm leaving out some of the parentheses stuff. I figure you can go back and look at the 2 numbers being multiplied. We also know that n of 10 times 1 minus p10 hat, we have to check for that being greater than or equal to 10. That number should come out to also 512, because remember it was a 50% approval rate. That's greater than or equal to 10. We also have to check the one from 2009. So we check the N9, P9, see if that's greater than or equal to 10. That number comes out to 535.3. I mean, 0.3. That's greater than or equal to 10. And then we do the N of 9 times 1 minus P hat of 9. See if that's greater than or equal to 10. And that number comes out to 474.7. And that's greater than or equal to 10. So when you're checking for normalness, the big idea, which is a little bit different than what we did before, is now you have to do it twice, one for each sample. Otherwise, no big deal. This is the part that we actually do some math. So what we're going to do based on our formula is we're going to take our ending number, because when you talk about change, you usually take the second thing minus the first thing to see what the change was. So we're going to take P hat of 10 minus P hat of 9, whatever that is, and we're going to go plus or minus our Z times the square root of, it's a big long thing, P hat of 10, 1 minus P hat of 10, all over our sample size of 10, plus, and then do the same thing for the 9. So then you have P hat of 9 times P hat of 9 over the sample size for 9. And when you do that, what you see in numbers, excuse me, is that you have 0.50, which was his approval rating in 2010, minus 0.53. Since we have a 90% confidence interval, that's a 1.96. And then it's the square root of all that stuff with the numbers plugged in, of course. Oh, wait a minute, that's not 1.96, that's 95, isn't it?
Yeah, it's 90%.
Sorry, my bad. 1.645, I think is the number that I wanted. And then in the first part, for the proportion of 10, that's 0.5 times 0.5, because it was 50% approval rating, and that was our sample of 1,024. And then that was plus, and then our second sample was 1,010. And the two proportions were 0.53 for the approval rating in 2009, which means that 0.47 was the, I guess I call them the failure rates. And so as I look at this, what I find out is that I get overall a confidence interval that ranges from negative 0.03 plus or minus the stuff from the right-hand side, which is 0.036, or in other words, an interval that goes from negative 0.066 to 0.006. So as you look at this and you think to yourself, man, in 2009 Obama had a 53% rating, in 2010 he had a 50% rating, it looks like he dropped 3%. But one of the things you have to remember is there's always error in polls. So when you do these tests of significance or confidence intervals, what they show you is, what does that mean for us? Do you think based on that interval right there that his approval rating actually dropped? I mean, who knows? It looks like there's very little change overall in the confidence interval. In our last part, we do the conclusion. And in our conclusion, we're going to say something like, we are 90% confident that the interval from negative 0.066 to 0.006 contains the true change in proportions of U.S. adults' approval of Obama from 2009 to 2010. And then the last part here says, based on your interval, is there convincing evidence that his approval range changed between that? What do you think? 0.066 to 0.006. It doesn't seem that there's a lot of movement there. And I guess when I look at that, I see that 0 is in that interval. And 0 means that there was no change. You have a little bit of wiggle room on either end. But overall, if I was looking for change, I might be looking for an interval that went maybe 0.03 to 0.06, or negative 0.05 to negative 0.01. That 0 is not in that interval. Because remember, 0 means that there was no change in the proportions. So I guess I would say, in this one, no, there does not seem to be enough evidence based on our interval, and I would add which contains 0, since 0 means there would be no change.
I'll try, dude.
So you guys can try to do the next example.